Hello everyone, I'm Binja. Welcome back to another video. So in this video, I'm going to be talking about number sequence and patterns. And as I said from the last video, this is one of my favorite topics in maths. Alright, so let's see what we are going to do in this video here. So in this video, we're going to learn about sequence and patterns. Alright, so what are the questions that are commonly asked in IGCSE exams are the next term and maybe even the nth term. All right, so you are expected to find the nth term or even to determine, to recognize and determine patterns. All right, uh what's that? All right, so I'm going to give you an example here. All right, so the example is example sequence number one. All right, I'm gonna give you a set of values. All right, for example 3, 6, 9, 12, and 15. All right, so what if the question asks you to find, all right, the question asks you to find the next term. Okay, so if at first glance, all right, so the pattern goes with 3, 6, 9, 12, and 15. All right, so automatically you know that the sequence jumps by 3. All right, if you can notice that it jumps by 3 by adding 3 to the next term. All right, so from here, if you are to find the next term, and the answer will be 15 plus 3, which gives you 15 plus 3, and the answer will be 18. All right, so this is the example of finding the sequence. All right, and the question will further ask to find the nth term. All right, what does the nth term mean? All right, so from here, uh, we will say that, all right, in this chapter, n is the term. All right, so when n equals to 1, n equals to 2, 3, 4, 5, and so on until n equals to n. All right, so when n is equals to 1, then the sequence is equals to 3, and so on. All right, so it goes like this. All right, and so on until when n is equals to n. So you are to find this nth term on how do you find the nth term. All right, so there are a few steps here to find the nth term. The first step is to determine the difference. All right, so the nth term is equals to the difference. All right, the difference, and then you will need to write the n difference times n plus with a constant c. All right, where you will need to equals to the term. All right, what does this mean? All right, so from this example here, the difference is 3, right? So the difference is 3n. Okay, so difference multiplied with n, so with 3n, and then you will plus with a constant term c in order to equals to the term. All right, so we can actually take any sequence in any number in this sequence. For example, all right, when n is equals to 1, sequence is equals to 3. So the term here is equals to I should not write the term here, should be equals to the value. All right, so the value here is the sequence, which is 3. All right, so the constant term and then the nth term here, how should I write this? Okay, is equals to value. So when n is equals to 1 and sequence is equals to 3, so you will get 3 plus c is equals to the sequence 3. Therefore, you get that c is equals to 0. So the nth term here is equals to 3n. All right, because if you sub the 0 back into the c here, you will get the nth is 3n. All right, so if you are to check this, when n is equals to 2, 3 times 2 is equals to 6, and n is equals to 3, then 3 times 3 is equals to 9. So this is how you find the nth term for a pattern. All right, so from here, all right, I will gonna be talking about the difference between different nth terms. All right, so we have a linear sequence and quadratic sequence. All right, and this two is actually in your syllabus, but I think IGCSE don't usually ask quadratic sequence and so on. All right, so what is the difference between the linear sequence and the quadratic sequence? So when you have a set of numbers here, for example, e.g., you have 2, 4, 6, 8, 10. All right, so this is the original, the initial row. All right, so from here we are looking for the difference here. All right, the difference is 2. All right, and then when the difference are all the same, then we are here at the first level. Difference 1, if difference 1 are all the same, then this is a linear sequence. All right, which means your nth term will be in the form of ax plus b. Okay, it's just that simple. All right, and this example is shown from the last one. All right, because at the first difference row here, it's all the same, which is 3. So you will get an n term, the linear n term. So it's 3n. All right. I think I should not use the x here. I should use the n. All right, an plus b. All right. So what is the example of a quadratic one? All right. This is a little bit small, yeah. Second example. All right. E.g. number 2. All right. I'm gonna give you 1, 3, 6, 10, and 15. All right. So by looking at the sequence, this is definitely not a linear sequence because at difference number 1, all right, I will just write it as D1. The difference here is plus 2, plus 3, plus 4, plus 5. All right. As you can see here, D1 is not the same. So we will continue down to D2. All right. The row number 2, where we get all is actually plus 1. So by this, all right, if D2 are all the same, then this is a quadratic sequence. All right, and then the nth term will be in the terms of an squared plus bn plus c. Okay, so I will give you an example on how to actually solve how to actually find the nth term for a quadratic sequence. All right. Okay, so in this part we will do quadratic sequence. All right, an example of quadratic sequence on how to look at a quadratic sequence. So from here, we know that quadratic is in terms of an squared plus bn plus c. All right, so we have a table here. Okay, when n is equals to 1, 2, 3, and 4. All right, we will do until here. All right, so when n is equals to the 1, 2, 3, and 4, the value will be equals to, all right, we will just sub the n inside here, a plus b plus c, and then here will be 4a plus 2b plus c, and this will be 9a plus 3b plus c, and the last one will be actually redundant, but I will just write it, all right, plus 4b plus c. All right, this is the value, all right, which is the sequence, all right, value or sequence. And then we will first look at d1. All right, d1 is equals to, what is the difference when the one value move to the second value, and from here we can find out that it's 3a plus b, 5a plus b, and 7a plus b. All right, so as you can see here from the previous one, when the difference row is not the same, we will continue to go on to the third row. Then d2 is equals to, all right, 2a, 2a. So 2a are all the same, right? A can be any value, which brings the difference row number 2 to be the same one. So we can further prove that this is a quadratic sequence. All right. So why do I show you this thing, and how does it relate to the sequence that I'm gonna be talking about? All right. So we're gonna look at here the example. All right. EG number, don't know what. Let's write number 1. All right. I'm gonna bring back the one just now, which is 1, 3, 6, 10, and 15. All right. So the difference row number 1 will be equals to 2, 3, 4, and 5. Okay, and then the difference row number 2 will be 1, 1, 1. All right. So if you compare the one with above, all right, since the last one are all the same, then by comparing, all right, by comparing, all right, this one, by comparing, okay, by comparing D2, okay, 1 is equals to 2a. Therefore, a is equals to 1 over 2. All right, can you see here? The D2 here is all 1 and D2 here is all 2a. So if you compare both of them, 1 is equal to 2a, therefore a is equals to 1 over 2. All right, then by further comparing, all right, let's draw a line here, green. By comparing D1, all right, by comparing D1, you can see here the first term here is 3a plus b. I'm gonna change the color here. All right, the first one here is 3a plus b, and the first one here is 2. Okay, so we know that 3a plus b 3a plus b is equals to 2. And then you know that a is equals to 1 over 2. So 3 over 2 plus b is equals to 2, and b is equals to 1 over 2. All right. And then lastly, by comparing, okay, by comparing the sequence. All right. So as you can see here, a plus b plus c is equals to 1. All right, so I'm going to use another color. A plus B plus C is equivalent to 1. All right, so we will further write down here. All right, A plus B plus C is equals to 1. And then from the first two parts, we get 1 over 2 plus 1 over 2 plus C is equals to 1. And therefore, C is equals to 0. So you can further prove that, therefore, nth term for the above quadratic sequence is equals to an squared plus bn plus c, which is equals to 1 over 2n squared plus 1 over 2n. All right, so this is the nth term for the above quadratic sequence. All right, so if you want to check, all right, so when n is equals to 1, so the first term will be 1 over 2 plus 1 over 2. All right, then it will be equals to 1, which is correct. So when n is equals to 2, so 2 squared is equals to 4. 4 divided by 2 is 2. Then 2 divided by 2 is equals to 1. So 2 plus 1 is equals to 3. And then if you continue to check when n equals to 3, n equals to 4, and n equals to 5, and so on, it will be the same. So this is how you look for a quadratic sequence. All right, so this is all about the quadratic sequence and a linear sequence. All right, so the linear sequence is actually very easy to look for the nth term, and the quadratic sequence is a little bit hassle there, but it's actually quite easy if you know how the concept goes. All right, so by comparing 2a is equals to the constant below, and then 3a plus b, then a plus b plus c. So yeah, we will move on to the examples here. All right, so here in the first example here, find the nth term of the following sequence. And the first part here we have 3, 9, 27, and 81. So you will need to recognize what is the sequence the sequence of the the given question. All right, so from here, if you are to look for the difference between them, all right, if you are trying to do d1 is equals to plus 6 plus 18 plus 54, and d2 you will further on to get something weird which is not making any sense. All right, then automatically you know that this is not the sequence that is shown. All right, so from here, 3, 9, 27, and 81, they all have a common thing. All right, this is 3 times 1. This is 3 times 3. And this is 3 times 3 times 3. And this is 3 times 3 times 3 times 3. All right, so you need to be familiar to this kind of sequence because it can be multiples of 2, or even square numbers of 2, square numbers of 4, cube numbers of 3, like this. So what does this mean? Because you cannot form any sequence from here, so if you further simplify this as 3 to the power of 1, and this is 3 to the power of 2, and this is 3 to the power of 3, and this is 3 to the power of 4. And this is what you will need to come in order to find the sequence. All right, so the first term here is equal to 3 to the power of 1. So if you would like to write this down, all right, here, let's make some space. All right, if you write this down, when n is equals to 1, 2, 3, 4, then the sequence is equals to 3 to the power of 1, 3 to the power of 2, 3 to the power of 3, 3 to the power of 4. So from here, if you compare both of them, you can see that the n here is equals to the power here. All right, if you can see all these, so you can further conclude that therefore you know that the nth term for the following sequence is equals to 3 to the power of n. All right, so this is a relatively easy one. All right, so we will go on to the second question here. All right, the second question here we have go down. All right, the second question here we have a sequence of 1, 2, 4, 8, and 16. So how do you solve this? So 1, 2, 4, 8, 16. All right, again, if you are looking for the difference, it's plus 1, plus 2, plus 4, and this is plus 8. All right, and you are further to find d2, this is going to be equals to plus 1, plus 2, plus 4, and never ending. All right, so this is definitely not the sequence that is supposed to be. So again, you need to think of what kind of sequence it can be. So 1, 2, 4, 8, 16. If you notice, they from 2 onwards here are the multiples of 2. So this is 2 to the power of 1, all right, and this is 2 to the power of 2, and this is 2 to the power of 3, and this is 2 to the power of 4. All right, so this is the sequence that you can get, but why is the 1 at the first term there? So what can it be? Right? Why is the 1 even there? All right, if it's just like this, we can further conclude that nth term is equals to 2 to the power of n, no problem. But the problem is here, we have a 1 here. All right, so this cannot be the nth term. When there's a 1 here, we know that, all right, anything to the power of 0 is equals to 1. All right, anything to the power of 0 is equals to 1. So if we see that everything here is the base is 2, therefore we can conclude that this is 2 to the power of 0. So all right, so if you would like to write this down here, when n is equals to first term, second term, third term, fourth term, and fifth term, all right, the sequence given is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4. All right, do we have until 2 to the power of 4? Yeah, okay. So now the nth term is no longer 2 to the power of n, because if you compare here, when n is equals to 1, it's equals to 0. When n is equals to 2, and this is equals to 0. So you can find out that the sequence is always 1 lesser than the n, the term. All right, so you can say that the nth term is equals to 2 to the power of n minus 1. All right, and this actually makes sense, right? Because if you sub n is equals to 1, it's gonna be 2 to the power of 1 minus 1, which is 2 to the power of 0. And when n is equals to 2, then it's gonna be 2 to the power of 2 minus 1, then it's equals to 2 to the power of 1, and so on. All right, so this is how you solve the second example, where you have a reduced power when you compare to the term. All right. And the last example I've prepared here is this one, 2, 3, 5, 8. All right. So this 2, 3, 5, and 8, right? So if you are to use the difference number 1 to look for it, it's going to be plus 1, plus 2, plus 3. All right, and then if you further go down to plus 2, you will have plus 1 and plus 1. All right, so in order to notice whether you need to go on D3, D4, and so on, you must have at least two common. All right, two common difference, in order for you to conclude that, all right, this row is the one that I should stop. So since you have until D2, all right, from the example here, we found out that when D2 are all the same, it's going to be a quadratic sequence, and the nth term is in an squared plus bn plus c. And then from here, we have proved that the 2a is equals to the common term, and 3a plus b is equals to the first d1, and then a plus b plus c is equals to 1. So from here, I'm not gonna do all those things again. All right, so we can straightly conclude that this d2 by comparing, actually we cannot write by comparing because we did not do the comparison here. So what we can do is we will straightly write 2a is equals to 1. All right, 3a plus b is equals to 1 because the first one here is plus 1, and a plus b plus c is equals to 2. All right, so from here we can slowly solve. A is equals to 1 over 2. 3 over 2 plus b is equals to 1, and b is equals to negative 1 over 2. So you will get here 1 over 2 minus 1 over 2 plus c is equals to 2. Therefore, you get your C is equivalent to 2. But you cannot stop here. You must make a conclusion that nth term is equals to, all right, a n squared plus b n plus c. All right, so this is the final answer that you can get. All right, if you are to compare, if you are to check when n is equals to 1, it's going to be 1 over 2 minus 1 over 2, then it's 2, all right? So the first term is correct. And we're going to check the second term here. 4 divided by 2 is 2 minus 1, which is 1. 1 plus 2, you get 3. And then if you check the third term and the fourth term, you're going to get the same answer too. All right, so this is how you do the hardest sequence that you can get in IGCSE. I bet this will be the hardest, unless you cannot recognize what the sequence is, maybe a prime number sequence. But I don't think there's an n term for a prime number. If they give you a if they give you an example of e.g., they give you 2, 3, 5, 7, the most they can ask is list the next 3 terms, right? So if you have to list the next 3 terms, then you can know is this 3, all right, 11, 13, and 17, because you can see that it's actually a prime number sequence. Because you see from here it's plus 1, plus 2, and plus 2. So the sequence actually doesn't make sense anymore if you are to use the difference row number 1 and difference row number 2 and so on. All right, so yeah, this marks the end of the video. This sequence is indeed quite a fun topic in my opinion. So I hope you guys understand this, and if you have any questions, feel free to DM me through Instagram. I'll try my best to help. So yeah, thank you for watching. Stay tuned.